Hello learners, in our earlier part we have learned about the basics of tannins, chemistry and its property. This module focuses on metabolism and bioavailability and effect of processing on the tannins. But before proceeding, let us now first see the sources of tannins which we usually consume. The different common human foods which include tannins are fruits, beverages, vegetable, some grains, cocoa or chocolate, then tea, coffee, wine contain condensed and hydrolyzable tannin, leading to estimated daily intake of human is approximately 1 gram of polyphenol per day through tannins. All known polyphenol responsible for the food attributes such as color, formation, astringency, bitterness, aroma. Condensed tannins, basically proanthocyanidins, are the most widespread in the plant kingdom than hydrolyzable tannin. The example of condensed tannins include coffee, tea, wine, red grapes, cranberry, strawberry, blueberries, apple, apricot, barley, peach, dry fruits, mint, basil, rosemary, etc. Hydrolyzable tannins can be found mostly in pomegranate, strawberry, raspberry, clove, barley, rice, oat, rye are the most common foods. Let us now concentrate on metabolism of tannins. Over the last century, the studies on tannins have been moved from industrial application, that is leather production, to organoleptic properties in the foods to the present day research in biological properties associated with disease prevention. Physiological effect of dietary tannins will depend on the release from food matrix and their absorption and fermentation in gastrointestinal tract. The action of digestive enzymes may release the fraction of food tannins which may be partially absorbed through the small intestine mucosa. Unabsorbed tannins and tannins associated with the cell wall reach the colon where they may be fermented by bacterial microflora, releasing some tannins and yielding different metabolites. Tannin absorbed in both small and large intestine may exert systemic effect. In small intestine, main factor that affect the fate of metabolism of proanthocyanidins is their degree of polymerization. It has been observed that proanthocyanidin dimers B2 and B5 are hydrolyzed to epicatechin in isolated rat small intestine. During small intestine digestion, high molecular weight proanthocyanidins may form a less digestible complex with protein, starch and digestive enzymes. Another important site where tannins become available in the gastrointestinal tract is large intestine. Most of the ingested proanthocyanidin reach the colon where they become fermentable substrate for bacterial microflora along with non-digestible constituents. The abundant microflora in the colon plays a critical role in metabolism of tannin that reaches the colon. There are two possible routes available: the breakdown of original tannin structure into absorbable metabolite or breakdown into non-absorbable metabolite. These remains in the colonic lumen where they may counteract the effect of dietary pro-oxidants in the colon produced during colonic bacterial metabolism. Let us now shift our focus to bioavailability of tannins. Tannins especially
hydrolyzable tannin,
have a very low bioavailability following oral ingestion. This is due to their poor lipid solubility and ability to complex protein. Since gallic and epigallic acid are hepatotoxic, low bioavailability of tannins is important in minimizing potential toxicity of this compound. Hydrolysis of tannins, mostly in the large bowel at neutral to alkaline pH rather than acidic pH, and hydrolysis is largely dependent upon the bowel flora. Let us now see the effect of processing on the tannins. There are only very few limited number of references are available which talks about the influence of storage and the processing on the stability of the tannins. It has been reported that elagitannins were reduced up to 40% after the 9 months of storage at 20 degrees centigrade, and the amount of ellagic acid in the frozen raspberry decreased significantly to 14 to 21% in the course of 1 year. Proanthocyanidins may be degraded during drying process of polymerized to a more highly polymerized compound, which can render extraction and quantification of proanthocyanidins in dried foods. Similarly, various processing procedures entailing the use of high temperature have been found to reduce proanthocyanidin content. For the example, it has been reported that after cooking fava beans, the processing of sorghum bran into cookies and bread, thermal processing, and the canning of peaches or the heating of the grapes. Let us now focus on the physiological effect of tannins. Over the decade, the studies on cell culture and on experimental animals treated with tannins have shown that this compound may exert several beneficial effects. It is believed that tannins may exert their biological effect in two different ways. One, as unabsorbable complex structure with the binding properties that may produce a local effect in gastrointestinal tract, and that is mostly antioxidant radical scavenging, antimicrobial, antiviral and anti-nutrient effect. Similarly, secondly, an absorbable tannins, probably of low molecular weight, and absorbable metabolite from colonic fermentation of tannins that may produce systemic effect in various organs. Several studies with different cell cultures have reported chemopreventive effects of tannins on breast, oral, prostate, stomach and skin cancer. Most of the studies have tested the molecules of tannins as present in the food, assuming that these polyphenols are absorbed to reach their targeted tissue to exert the potential anti-carcinogenic effect. As we have seen the beneficial effect of tannins, however, the anti-nutritional effect of tannins have also been reported in many studies. Let us now find out that first, tannins may reduce the intake of legumes by reducing the palatability or negatively affecting the digestion. The astringency sensation caused by the formation of complexes between the tannins and salivary glycoproteins, which may affect, increase or decrease the saliva. The second factors, the tannins may affect the fiber fraction digestion. Tannins may reduce the cell wall digestibility by binding bacterial enzymes and forming indigestible complexes with cell wall carbohydrates. Hope learners, you have understood the bioavailability, effect of processing and the metabolism of tannins. Let's conclude. We have seen both benefits and side effects of tannins. Tannin also hinders the absorption of micronutrients, mostly dietary iron. Hence, it is recommended that while planning a diet for the patient, the benefit and side effects of the tannins needs to be considered.